Hello! Hi and welcome to 3D Print Tech Design and this stream. Hopefully the sound is good, the level is acceptable. Woo, that's that's a sharp voice, I need some water. So let me know if the sound level is too high, too low. And yeah, welcome to the stream. So, super, thank you Patrick. So as I was talking about in the description, this is the goal here. I bought myself one of these water jets. I don't know why. It was cheap on Banggood, so I pulled the trigger. And the plan is to create a boat around this. As you can see, I already put on the motor. I also have the ECS, electronic controller, and all that stuff plugged in, just to be able to test it. And I tested yesterday in the sink, and it seems to be working. So yeah, I needed to print like a spacer for the motor, but everything hardware-wise works. So with that said, I think we should make something out of it. Super, Nomana, thank you as well. So yeah, let's jump into the computer. And ooh, it looks weird. There we go. Hopefully you can see this. Nomada Tech, I haven't done those planes. I haven't modeled any of those. So I'm not really sure what you're thinking about. If you think about the lines, they have like ribs printed in a direction the last time I looked at one of those planes. And I assume that's basically doing offset planes and maybe creating a thickness, and then you intersect your body. We can probably do something similar within this boat. So yeah, I'm building a boat. I have been playing around a lot with Fusion 360, basically modeling all of my parts that I have, all of my RC parts. Okay, those ribs, it's probably just like an intersection, and then you thicken that intersection to get thicker parts. So I've already modeled this part that we have here, so I'm not going to bore you with that process. I just want to show you that I have it. We should be able to do a good looking intersection here somewhere. So you can see here, this is the like the design of one of these jets. And hopefully, yeah, the plan today is to create something with it. So if we look at the part here, it actually consists of a few different parts. So let's hide it again. This is the extension that goes outside of the boat. So we need to design something that fits against this surface and have a hull that is probably flat, and the hull should also connect to, of course, this extension part. Then we have the nozzle, and this is something that can, if we can drive this here, this joint, drive joint. So this nozzle will be controlled by a servo, and by moving this you get steering power. So we don't even need to model a rudder. So that's pretty nice. We of course have a propeller on the inside. I haven't really done anything about that. It's just a basic model. We have the inlet. This is like underneath the boat. So if we hide this, this is actually our contact surface. So we need to model something that is flat on the underside as well, so it's easy to print a connection here and get a tight seal. I was actually thinking about doing some O-rings, but maybe that's a little bit too much work. Glue and hot glue is always a good solution when you don't want to do too much. What else do we have? Yeah, we have the shaft coupler. So this is the shaft that then couples onto our motor. And that should be our start. I also, of course, modeled the motor. It's not really that interesting. But this has been really good practicing. So if you have a lot of parts yourself that you might want to get learning some Fusion 360, I think it's a really good tool to just take your caliper. Where's my caliper? To take your fancy caliper and your parts and basically just draw them up in 3D. So as you can see on the left side here on the screen, I have built myself a little bit of a catalog of all my RC parts. On top of that, I have also started some projects here. I also have a lot of the screws and bolts and magnets and everything like that I'm using, just so I have them and can put them together in the scene. So speaking of that, I think it's time we create a new scene. That's how we're going to start with this. And one of the first things we got to do to be able to bring in components is to actually save this scene again. So let's call this RC Jet Boat Building. Now when we have it saved, we can start to bring in the different components that we want to reference. So we'll put that into the middle. We also need the motor. We can move this around. We can align all of these things later. We also need, let's see, what is this? This is my receiver. You don't really need to use the receiver right now, but it's a good thing to have things in here and just see how much space they take. We also need the electronic speed controller, ECS. Put that here. We also need the battery, of course. Battery is good to have. So this is a way to roughly get a shape and like a volume. So how much stuff do we actually need inside the boat? Okay, so maybe one of the first things we should do is to align the motor to our connector. So I'm moving by points. And then if we move this all the way to the surface, they should be flush. And I'm pretty sure that in reality, these two shafts actually break or connect to each other. So we want to move this back a few millimeters, let's say 4 millimeters. So that's going to be our basic distance between these two so we can connect them. And you can see I've already modeled the screws here. So it's we already know how we're supposed to bring things together, which is a great help when you're doing more 3D modeling. And the other parts we can fit somewhere else later. We don't need to think about those right now. Okay, so I'm going to start with creating a new component, and we're going to call this hull. And the thing is that I'm not entirely sure exactly how I want this, but I know that I want to have a boat and I want to have a pretty simple body so it's easier to 3D print. To be able to slice in the middle and just print sections. That's my goal at least. And I want to create all of these parts in form. And my idea was to create a pretty simple form to begin with, and then create a shell, a thickness on that. I have a small ambition of having this being able to print it in like 0.8 millimeter nozzle by 3 layers or something. So I really want to keep it evenly thick around the whole shell, which should make it much easier to slice and to print. That's my ambition, my goal. I'm not sure I'm gonna get that exactly as I wanted it. So before we actually create our main shape, I think we can start to do some sketching and some drawing up, just playing with the shape and see what we can create. So I'm gonna save my file in case things crash. I'm going to minimize the parts menu here so you can see a little bit better what I'm doing. If it's too fast, too slow, just let me know and I'll try to adapt the pattern as well. Great. Patrick, yes, I'm just, I don't want to, I could create a joint, Martin. Martin is asking why I didn't connect these two parts by a joint. If I would have needed to simulate movements, I would probably do that. So when we're going to connect the servo steering, I will probably do that via joints so we can see how everything moves and do some calculations on like what angles to put the servo at. But for now, all I need really is the distance between the motor and this shape, and the axles to line up. Nothing else really matters in this case. I have, as you can see here, I have modeled the wire connections on the motor. It doesn't really matter, but it's good to know that it's in one direction, and it's either upside down or this way. So then it's easier to actually plan out where the wires go later on. Okay, so we have our component hull, we have that component active. So let's go ahead and create some shape here. There are a lot of different ways of creating a boat hull. One of the fastest one is basically creating a box. So we're going to create a box at the center of everything. We are going to add some mirror symmetry in the lengthwise. So if I model something on one side, it's going to replicate on the other side. Let's see here. None of these really matters because we can add and change all of those settings later. And if you know me, I'm also talking a lot by modeling in box mode. So I'm going to display mode under utilities. I'm going to select box mode. And that just makes everything much easier to start off from. So we have a few things that we know we need to do. And especially that is we need to connect to the bottom surface. So I'm going to move these down. I could actually reference, but for now we're just going to move this down. And one thing, so around there, somewhere near, we'll connect all the surfaces later. We also know that on the back here, we want to move these roughly to where it's supposed to be. So roughly around there. Yeah, another thing is that now I'm starting to plan out the hull. Again, this is the play shape, and then we'll do something more serious. But I want to kind of figure out how we want the boat to look, and I want your input on what's looking good and what's not. But I'm going to say this already. When you're doing the shell, which means that you're thickening this body, it's really important that you think about which direction you want to thicken it. Do you want to thicken it inwards or outwards? So currently I'm planning to thicken outwards, which means that it's easier for me to connect surfaces towards things. So like this backside here, that is actually now, I'm not going to say that it's connected, but I'm aligning that towards this spacer here, this room here. Which means that when I thicken this, it's going to thicken outwards toward the nozzle. Okay, so let's start with some modeling. Let's see, I think there is good. You can still see the menu there. So I usually select in loop, and then I move things around. Since we're doing a boat, I'm going to delete the top because we can always create a lid later. It also makes it a little bit easier for you to see what I'm actually doing. Oops. There we go. We'll delete that. So what I'm doing now is I'm in the form mode. I have the box mode on. I'm also moving everything by the edit form tool. So it might be a little bit fast here. I'm trying to not do things way too fast. So I'm starting with some sort of boat shape. I'm not exactly sure what we're what the plan here is. But a boat is a boat, which is usually not the hardest shape. So for example, now I want to add details. So I'll select a loop. I'll click the Insert Edge tool and just drag that over to roughly where I want to have it. So there, see, I have a new loop, and I can select part of this model, for example, and start to scale outwards or just move around where I want to have it. It's all very boxy right now. So if I wanted to let's just play around a little bit more. So if I actually want to see how this looks, I have to turn back on the smooth display mode. As you can see, things are very round. Things are not very defined yet. So yeah, to do something serious about this, we need a little bit more details. Now, there are areas that I might want to have perfectly flat. So to do that, we can add a crease. So I'm going to crease this section here. You see these lines, and that means that we have a perfectly flat surface towards the nozzle in the rear. We can actually do the same. So if we go back to box mode, I think this is going to be easier. So we have this this line here that we could actually we could insert an edge on that, roughly there, and let me just do some simple flow with lines here. So if I create a rougher shape here, we can then take this shape and crease that as well. Let's go to crease. Select these lines. There we go. So now if we go back to the smooth mode, you can see that we have created these lines here. These are now perfectly flat as well. And I think that's going to help with like the jet entering here. So we have this module where we want the jet to be able to bring in water, bringing in water into the whole motor and the whole assembly. So we could actually, you can see now that our motor is actually intersecting with the body. So we would probably have to bring all of this forward. So we can do that. You see, if we bring this forward, we create a flat surface where the motor is located as well. I think it's quite dangerous to really model a lot in this mode. I prefer doing it in box mode because you can see that we don't want to do too crazy stuff. We need a bigger, but yeah, it's probably be too small. It's gonna bounce away. But that's the plan. The plan is to bring everything into the front. But I really recommend to model a lot in the box mode because it helps you understand where the lines are, and the cleaner your lines are in the box mode, the better they will look and the cleaner the surface will be in smooth mode. So I think Patrick is giving us a pretty good tip, and that is that we should probably look how big this boat actually is. So if we just finish this shape, you can see that we have something. I don't want the boat to look like this, but we have something. What I do want to do is to actually step back into the history. I want to make an offset plane. Let's go to the back. What's this? That surface, that is 35 millimeters. We can drag this out to just make some sort of line. If you didn't know, you can drag in the construction planes to increase the size and orientate yourself a little bit. So if we take from there and forward, how long do we actually want this boat to be? 30, 40 centimeters, 35 maybe? Let's go with 30. 300. I mean 300 millimeters. What do you think about that, Patrick? Is that a reasonable size? 35. Okay, Patrick is the boss, so let's go with 35. So now we have two planes that we can kind of look at. So if we go back to the hull, we have a lot more boat to create. So I'm just going to double click this shape. Unfortunately, Fusion does something weird. It keeps the body below, so it's always really annoying here to see kind of how it works. So what I like to do is that I actually, before I go into the modeling, let's see, why do we have two bodies? I don't know why we have two. I'm going to delete that one. So before we actually do this, I'm going to open up and hide this body, because if I start editing, then I don't have something interfering. I don't really know why they're doing that. Of course you are, Patrick. So yeah, with that said, I think we can basically just move everything forward. So we start to get the hole somewhere around there in the front. We can do all the details later. I also want to decrease the, what's this called? I don't even know what this the hull shape, something about the hull. Ooh, there's a strange line. So let's bring that forward. So I'm thinking that I need to add some details around here because I want to have a pretty cool looking rear of the boat. So let's move these two outwards and maybe back. Can bring this back here as well. I was kind of thinking about having a shape going down like this to kind of stabilize the boat. My ambition is to have a boat that can kind of handle driving upwards of creeks and streams. So I kind of want to have a small nimble boat that can take some water coming from the sides and things. I'm not exactly sure how I will achieve that, but I think that would be pretty fun to do. Again, we creased all of these surfaces when we don't really need too much up in the front. So let's move these back a bit. Widen, oops, not widen like that, widen like that. Hey, Daniel, nice to see you. You're also building a boat, right? So, okay, now I'm doing a lot of stuff in the hard mode. So let's go back to the soft mode and see how it looks. I think it's still too wide. We needed to cut through a little bit more. So to be able to create details, what we can do is that we can actually do something else. I was adding lines before, but another great tool is the bevel edge tool. So if I select an edge with the bevel edge, we can kind of drag it around a little bit. I think something like that will be good. So what we're doing then is that we're creating another edge around that. Sometimes that's not really nice. You see the connection here is not really looking well, so I usually take the weld edges tool, click on the other, click one on the other, and kind of bring these lines back together. Something like that. So let's look at that in the sharp mode or in the smooth mode. You can see that by bringing two lines together, we're actually starting to create some sharpness here. Now I'm probably need to move this up a little bit. So if this is going to be anywhere near what I want to have a kind of flat back, so when the boat kind of hits, it will stabilize a little bit. And it's probably going to drive a lot of upwards in water. So something that can help stabilize that a little bit. So something like that maybe. Let's drag those out even more. We can also start to work a little bit with this surface, rounding that up. I'm not sure how much we should round this surface up, but maybe a little bit. Just pulling these ones up. And probably we want to have a sharp surface down here somewhere. It's not that line. Kind of depends, everything here depends on how it will smoothen out. Move this back a little bit. Twitter! What's happening on Twitter? Hey Michael, nice to see you as well. And John, nice to see you too. So, okay, let's try another in the smooth mode. It's looking pretty weird, but we have this nice flat surface where our motor mounts and everything are going to go. And the top is not really looking good. But you see what kind of shape I want to have. I want to have something that helps like flip the boat correctly. Yeah, Daniel, you're the ah. Oh, I thought that would be but I thought your boat would be RC boat as well. Okay, so it's not really working here. I think this is just too much. So let's bring this back in a little bit. We can have some surface there, but I don't think we should overdo it. Let's move these backs a little bit to get some smoothing here. Let's move those two out. Something like that. I think we can actually sacrifice some surface around here. Probably do... I mean, I guess I kind of want to have this sharp down there. Isn't that how a boat looks? So you have like sharpness in the front. I don't know how boat looks. Ah, I think I misread your comment and Daniel's comment, Patrick. So I kind of want to have an attack angle here, but I'm not sure exactly how this is starting to look. So let's increase the height a bit of the boat, so we can start to do works a little bit more on the front, and give ourselves some more like actual body shape to work with. Okay, how does this look in smooth mode? We're starting to get there. Is this crazy looking? That's curtain holders, nice. I'm not sure what you meant, Michael. Michael is spamming. Interesting. Weird. I think we can actually start to, if we do like this, if we uncrease that edge, how will that look? Because it's actually only this part that I want to have perfectly flat to mount the motor on. The rest can be more creative. I'm not sure if this is creative, but it's something. It's a bit weird. I'm not sure exactly how this will like float. We might need to bring this up somehow. So let's just look how that would be if we brought up. I'm guessing that we want the jet to be far down, and we want it to float a bit deeper. I mean, it's gonna be pretty light, I think. I'm not totally sure that I like this. Maybe. Okay, so let's go back to the box mode. Yeah, we need to do something about this then. It is our first example of shape. But again, the whole goal is to like navigate sharp rocks in creeks and water streams. That's kind of like how I envision this boat to be to work. So if we just finish that form and kind of have a look at it, because I'm thinking that usually the water will hit. I'm not sure. What do you think? Maybe work a little bit here on the back so it looks better. Maybe easier to print as well, like a flat. It should probably be a completely flat surface we can print it. It looks fast, that's for sure. So yeah, let's do that. Let's go back in and make sure that this whole surface is perfectly flat. I think that's going to be really important to make it printable easily. So what's that? Then we can remove these ones, I think. Maybe not those. We should... These ones should be creased. We can uncrease these ones. And those. So we take this flat surface here, all of these points, and we will, what's this called? The tool is called flatten. Select the plane, and let's just hide this one here and select that plane. So now we're doing a completely flat and we have everything creased. So if we look in the smooth mode, okay, so something, it should be flat. It probably is flat. But that makes everything much easier to print. So if we finish this form, all of these ones should be, I'm not sure that they are, but those should be perfectly flat, which I guess is kind of important to be able to print it. We can probably, we might be able to add some shapes here. So you can kind of print and glue on or screw on some parts if you want to have more. Let's think here. All of these has to be creased, right? And also, I'm guessing those two. Yeah, it's flat. Sorry, there's a lot of distractions here. What I'm thinking is that we could continue with these shapes. So these shapes could possibly... oh, how do I show that? Can I do it like this? Yeah, I can. So I'm thinking that maybe we could work with these shapes, creating something like this. But having all of these still being creased, that's a nice rhyme. That should mean that when we smooth this off, we would get parts like this, but they would be easy to like screw on. So you would just screw them on from here. So we have a completely flat surface, but then we can screw on pylons or whatever it's called to, like, I don't know, make some cool jet behind the boats. Let's worry about that later, because I'm still not really sure about this part here. I'm not sure it's acceptable. So what if we only have it flat? So let's do something like this, where we create something that helps like push the boat down, but it doesn't go in. It's still like flat here on the back. So we don't get a lot of weird shapes. I'm thinking maybe something like this. How would that look? That's like a more traditional boat shape. What do you guys think about that? Do you think it looks better? It's also much easier to make a top for. It is pretty deep down here, but we have the motor that we kind of have to worry about. Oh, by the way, the motor is in the wrong place. We should fix that. We should move the motor. I don't know, I think I removed something before. So let's go ahead and redo that. Point to point. And then, there we go. And then we move this one. Click on that one so they connect. And then take like so. So we have 4 millimeters between here. Yes, 4 millimeters. Awesome. Capture that position. Now we can go back into the hole and go ahead and step forward. So now we have a little bit more room to play with when it comes to the motor. So we could actually move this back here. Oh, wrong mode. So let's move that back, which means that we can move this back as well. Maybe move it down a little bit. Maybe out as well. I wish I knew more about boat building. Patrick, I'll see you later. Thanks for stopping by. Yeah, we're starting to maybe achieve some shapes that I enjoy here. Now, if you're new to the stream and wondering why I'm doing this flat surface, that is because we have this jet engine, this water jet down here. So what we can actually do, I hope that we can, is to hide some of the parts like that inlet thingy. Neil, yes, there will be issues with fitting parts together that I'm gonna try to solve. This shape that we have right now, that is so we have something to start off with. Then we have to create flat surfaces towards different parts. But basically my goal is to print it in this direction. So it prints upwards like this. So this is connected to the build plate. And then I will probably chop it in different sections. So every new part that prints from the bottom will have like a rib that we can put on the build plate and also add some strength in it. You would probably have to do some gluing, some maybe... I'm gonna go ahead with gluing. I mean, if you have a printer that is 350 millimeters in Z, you could print it without having to like chop it up. So I think I actually went a little bit too far on this surface here. So let's go just back a little bit step here. And I can also see that I haven't, did I crease these ones here? Yeah, those has to be creased. But I should then flatten these surfaces. They should be perfectly flat. Where we go, flatten, select a plane. I'm gonna hide this here. And I want to flatten them against this surface here actually. Yes, there we go. So now all of that is flat. And actually I can see that my motor is actually going through here. That's not really good. That's not what I planned for. Did I do something wrong when modeling? Because in this model, you can see the motor does not go underneath. This is not good. Something is wrong somewhere. Maybe it's... That's weird. Interesting. Okay, well, we'll work with that. I'm guessing maybe it's the coupler. The coupler is in a different position. I think everything is a bit further up. Anyways. Yeah, I think the motor is actually a little bit tilted. Yeah, it is tilted a little bit upwards. I did not account for that. I can't really measure that angle. That's gonna be interesting. We'll have to do some adjustability. It should be aligned almost with this line here. Almost. Okay, well, we'll think about that later. We'll create some space for it. Okay, so how does the front look? Let's focus a little bit more on the front. I think it looks pretty good. Maybe we thin and like sharpen it a little bit. Let's go back to the box mode. So I think that what you want to do is to thin down a little bit here so that it's sharper and then like grows outwards. Should be the same down there. Because we kind of want to cut through the water. That's looking pretty decent. So let's do another thing here before we finish, and that is to move up a few millimeters. Let's go with 4mm, 5mm lid. And then I select this whole loop and crease that one. Which means that if we get like a perfectly flat, thick surface that we can much easily work with later on. Good. So with this body now, we should be able to go into the surface tool, modify, and create and thicken. And I want to take the whole body actually. I want to make it, let's go with 3mm, that should work. So that's a 3mm thick body. Oh, I have the sun in my face. Give me 1 second. Let me know how thick do you want the printed plastic to be? Suggest a thickness for the hull. I'm just gonna close the blinds. Okay, there's still some sun in the eyes. Maybe that's better. 3 sounds good. Okay, let's go with 3. And it's also important here that we go outwards. We could go -3, but this is +3. So you can actually see that we have a body now. So in theory, we could start working with this one and yeah, make spaces and make cuts and everything. I think this surface here looks a little bit weird. Let's go back and look at that. So we hide that, we click here. Go into the box mode. Okay, so here is something slightly weird. Okay, so it's this shape here. This one should in theory be up there to make everything work better. Oh, it's probably this one here. We don't need those. So if you remove that, things would look better. So if we close, we have some issues here. What are the issues? So we have too many lines. So if we weld this to that, I think that solves it. It should do. Let's go ahead and crease, just make sure that, yep, everything's looking good. Does it work? It works so far. Yeah, I'm probably gonna add some ribs for sure. And why doesn't it work now? Okay, so we got some issues with the thickness here. Okay, so there are some issues. Let me see if I can fix them. I think it's these lines here. We actually don't need all of this. I'm gonna delete those because this should all be a flat surface anyways. So if we go like that, let the computer think a little bit. Show that body. Okay. One more thing here. Sometimes what you can do is that you can repair the body, and we have some issues here. I'm gonna auto repair. That looks good. If I finish the form, it can thicken it. So there you go. Sometimes things are wrong. This doesn't look good. I want that to be, yeah, that's not supposed to look like that. So how do we do that? We go back, we edit the form. Exactly, we don't need these ones either. There we go. If I remove those, then it's better. That's sharp and nice. There we go. Now it's a perfectly flat surface and it looks good. And of course, what we can do here, or we should be able to do, is to add a chamfer to kind of round that off. I mean, we want to have a perfectly flat surface, but we don't need to have like perfectly flat edges. So if we round that off a little bit, it looks better. But we can add that tool later. Let's not do all the small details right now. But there we go. That's starting to look like something. Yeah, it's interesting about the motor, because if we do an inspection and section, look at this. You can see that we have space for the motor and everything. It's just that we kind of need to figure this out and exactly how we're supposed to mount it. Interesting. And also, I think that, I mean, I'm thinking about how to get a watertight seal like around here, but I'm guessing that hot glue is going to be the perfect solution. I'm probably going to just do hot glue. So, I think I want to worry about the lid later on. I'm going to do the lid at the end, which means that we are probably ready to start doing some ribs and detail work. I think. So everyone's that's watching, what do you think about the lines? Do you like them? Do you think they look good? Is there anything you would like to change before we continue starting to add details? Do you like this body, or do you think it looks stupid? Maybe actually now when I'm looking at it, maybe I want to do something about this here. It looks a little bit weird. Why does it look so weird? Awesome, Miguel. Thanks. Yeah, I think it's like safe enough. for what I'm doing. No. I haven't mounted the motor. So if you, sorry about the volume there. So if you look at this here, this is our reference parts. But as someone said, I have actually modeled it a little bit wrong. You can see that the motor is put on an angle. So the motor, right now it looks like the motor is like offset, but it's actually going up a little bit. Let's see if I can show. There you see. So there's an angle to all of this. So that's something that we have to figure out how to solve. It shouldn't be too much of a problem. I need to mount the motor probably by like squeezing it. So the first thing that I'm gonna do is to plan out where the ribs, and in other words where the boat is split. So if we continue we're doing a offset plane from this one here, I'm thinking the first good space would be to have a rib between here so we get some strength. So if I do a sketch on that plane, this could be as simple as just intersecting the whole boat, but then again we need to make it thicken. So how do we do this? It does narrow down. So if we only intersect like these parts here, and of course down there, I'm gonna hide the body here as well. So that would be one of our intersections. We could probably we could cut that line so we get a surface here. We need to have, of course, things are not exactly centered. If we also project the center of that shape, we could make a hole. Let's make it a little bit bigger. Let's go ahead and do it 12 millimeters. We also need to make hole for the screws. Let's see, 3.5 and 3.5. And usually what I like to do is to select all of those projected lines and just make reference shapes of those. It's a little bit hard to see here. But this is basically the plan. So if I extrude this, so let's make something, it should be, by the way, 4 millimeters. Remember we talked about where the motor was. So like the distance here between, and that should be 4 millimeters. And I want it to join, but I'm gonna remove everything else. So this would be one of the first ribs. So hopefully, now when we're printing this, I'm not sure exactly everything is gonna go in. Yeah, speaking of that, how do I solve this? Because the housing is actually sticking out a little bit. So if we hide the body here, so you see this part here will be a little bit tricky to like push in. But hopefully you will put in the jets before the different parts. So you see the plan is that, okay, let me show that quickly. I know I'm jumping back and forth a little bit here. But what I'm thinking is that if we split this body on this side, that means that we actually we mount this part of the boat first. So you would mount like the water jet and everything, maybe even glue that down. And then you move the rest together, put on the motor, screw the motor shut. So I guess it works out. And then after that you would have to put in the motor mounts somehow. So if we do like this, everything should work, and all of these parts should be quite easily printed. We could even like make a lid over here, so we actually only have a lid on this part. We'll have to see. So let's just skip back a little bit. And with this first rib, I think it's also important that we maybe think a little bit about what do we actually want. Do we want to have all of this surface thickened? Yeah, absolutely. That's exactly what I'm planning, Michael, to add some like some holes in this rib. So one fun thing would be, of course, to just get some sort of reference here. So if we move this in, let's say 10 millimeters, and just add, I don't know, 60, and then we can create, let's go ahead and just do a mirror line here. So we could, for example, arc between this point and that point. Should be able to. Oh. Of course, it's circle. So we do a 2 tangent circle. Nope, we can't do that either. We do a 3-point circle. Isn't this how you do it? I can't remember how we do a smooth. Is it 3 tangents? No. There is some way to make a good. Is it arc maybe? Tangent arc? No. We can of course do like this. We'll just trim everything. trim, and then we smoothen out that curve. Why doesn't that work? Can we trim here? I don't know why. I don't know why, but we have to be able to do it somehow. Let's make a 2-point circle. Nope. I guess a 3-point it is. Doesn't really look what I want to do. Yeah, I thought I would be able to, but I think it's a projected line that is then offset. I think that might have ruined. And then there's of course the mirror here. Maybe if we do like this, remove that one. We finish this, but we select what we actually want to extrude. So let's remove that one. I think just to test, we should be able to, yeah, okay, we can fillet this. I think it has to do with references of everything. So we'll do a fillet on this later. So let's go ahead and go back and maybe create, let's just make a box here, maybe 20 millimeter wide. Something like that. There we go. And then we can do the fillet that we want to do. And I'm guessing that this should be enough. I mean, maybe I will add, let's see, let's go with 10 there. I might add some space for the battery. I'm pretty sure I want the battery over the jet to really get the weight down around here. So I'm not exactly sure how I will do that. Maybe some screws and like a rib or something that we then place the battery on. But this should be able to house. We need to have, of course, the the servo here as well, which is going to be quite far down. I don't want it to be too... By the way, we can also... Okay. That's true. The battery should probably be further front. We'll have to shift that around a little bit. Yeah, you're right, Michael. We have to think about that. Again, if there's any water coming in, it's probably going to be back in this rib here. So maybe we should like increase our goal here. So I'm not sure. I'm thinking like actually doing something like this. 27%, that's awesome. I have no idea how to get that done in here. By the way, why my mirroring isn't really mirroring, which is a bit scary. That means that something isn't symmetrical anymore. But it's also projected lines. Okay, let's finish that. And this one here, I want this to be 25. That should add... That's going to add some place here. Oh, but of course the water is going to go through here. I think I'm smart, but then I quickly realize I'm not. So any water that gets over this level, that comes in from like the jet or somewhere around the back here, any water that comes in there is going to flow into the motor. 27%. But there shouldn't be any water. That's the idea. 27 to 33. So from the back, right? Taskin. Okay. Interesting. Nice. Okay. Okay, but that should be around the motor. We'll have to think about that. I mean, the battery is... This is the size and weight of the battery. So in theory, we could place it anything from... Like that's probably... Let's do science here, okay? So let's let's take a plane. And what was it? We had... is the boat taller now? 370? I guess the boat is 370 millimeters now. So anyone quick at math? How much is 30% of 370? Isn't that like 100? I'm googling faster than you. That's 111. So 111. This is where we should have the majority of the mass, which I think will work pretty good. The battery and the motor are the heaviest. I mean, that outer part weighs nothing. So in theory, we could place both the battery like around there, and if that's too far ahead, we can always place the battery like this around the CG, and we should have space for that, even quite far down. It doesn't look good that way. We could of course also make a hole in the rib, which would be pretty smart because then the battery won't flip out. So maybe we should do that. Yeah, let's do that. Let's imagine that's where we're gonna have the battery. And let's take some quick measurements of the battery. It's I could reference it, but I want to move it around. So it's 47 by 21. 47 by 21. Yay! That's awesome. My bot is communicating. Yeah, so let's back up to the rim. let's think about how we can place a battery in here. That is, what did we say? Let's go ahead with 50 by 28 to have some margin. And if we move that down a little bit, we could actually go with a good number like that. That means that, and then if we do like this, let's make it thicker. Let's make 4 millimeters. Trim, trim, and trim. Yep. I am I'm doing some modeling now without really talking about it. But I'm basically adding a crate for the battery. So if we hide this one and we do the extrude is not going to be these parts. Like so. Good. And this here, the fillet here should now be like only these parts. Let's go ahead with 6. Oops, not that one. Jesus Christ, I'm already doing all the details, which which I didn't want to do just yet. Maybe 2. There we go. So that means that later on, if I want to place the battery somewhere around there, I have the space to do it. So I can shift the battery back and forth to create a good balance. All right, that's one way of doing it. Okay, let's continue with the next step. We should have a rib somewhere else. We of course have our receiver and the ECS that we want to have somewhere. So maybe let's do another stop. So from, where's that construction plane? From this plane, let's go ahead and move this forward. Let's see, what is the length of the battery? So we need to be able to put the battery down and then shift back and forth. So then we have to have a distance between the ribs. And I'm measuring in real life instead of on the battery, which is weird. But that's 90 millimeters tall, roughly. So if we do this 100 millimeters, or even 110, that means that a lot of printers that have like 125 or 150 in height should be able to print it. It does. Maybe you're thinking about this plane here. I think this rib should be pretty nice inside here. On the left side. I think that's just a detail. This is like a sharp edge that I want to have. So I think it should be good. So let's go ahead and no worries. Let's make this. Whoops, I'm doing weird stuff now. So let's do the same thing here. We're going to intersect the hull of the boat and intersect all of these parts that we need. There we go, that's our line. So let's go ahead and do something similar on this one. So we'll hide all the bodies. We'll close it off. We will actually, so to make sure that we are, let's hide the battery as well. So what I want to do now is to project this pattern here again for the like the battery compartment or holder. So I'm just gonna take that same lines and create those here as well. So we have that that like hole. And let's let's see. We can do an offset of maybe all of these shapes. I think we did 10 millimeters before, so let's do 8. And we get a good intersection and good things here. And I think that we can have this holder as well. So I'm gonna go ahead and extrude this. Oh, of course, we need to have something up here as well. Let's go, let's just make a line parallel to something. And then we'll do a distance between that. And let's go ahead and say 8 millimeter there as well. There we go. And when a computer thinks like this, it's a good reminder that I should probably save. Let's finish the sketch, save. It's always good to save. And then I want to hide the previous sketch because it's kind of messing up here. I'm actually going to go back in and start doing some trimming. Like so. And now if we extrude this profile, let's select everything that we want. Let's go with 4 millimeters as well. And that should be into the body, so we should join. But we need to hide everything else so we actually don't join it with something else. Like so. Oh, by the way, we should not join it. We should make it a new part, a new body. And then we can do like all these chamfering and stuff. Or fillets, that's what they're called. Let's go with 5. Maybe 5 is a bit too much. 3 should be good. Sometimes I wish that it just did everything in mirror. Maybe 4. 4 looks good. That looks really good. So we have our different compartments. We should probably do one more rib, so like halfway here. So if we break the boat, it's probably going to be in the front, so then it's even easier to repair. But let's reintroduce some of our parts. In theory, we could do like a plate underneath the battery here. So a plate that you screw in, or yeah, a plate that you just screw down, really. That should work as well. Yeah, okay, let's think about that later. That's gonna be our details. And yeah, to be honest, the motor is probably a little more in an angle. I think it's really hard to know exactly the angle, but it's probably something like that. So if we just add that for now, it's going to be a better reference for us later. It's really hard to measure those angles in real life. I don't have any tools for that. So let's just imagine that it's something like this, which means that we need to have some space to actually clamp down the motor, which is going to be a little bit interesting. And we also need a space for the this electronic speed controller and for the receiver. So one thing to do that is that to actually start to create like ribs for those. So if we decide on a plane here, like not a plane, a height. Let's see. Here we go. So if they should be somewhere around the battery, that's 30 millimeters up. Hey, thank you so much, Michael, for the help with the bills, the bears, and the bed leveling. Thank you so much. Yes, hopefully I'll be here like an hour more or something like that, and then I should have something that I can actually test print. I might not have a lid for it, but I should have something that we can test print. I can start to run a few files, and basically over at Patreon I will show more of that process. Of course, film everything and get that done. Thank you so much, Michael. So that's going to be super nice to have, which means that we might have to do something about like the angle in this rib. I might have to test that. I might have to test like do a small version here that we're going to print. Now, I'm going to do some pretty interesting stuff here right now. So if you're curious on how to do, by the way, I'm increasing the height to 35 millimeters here. So the plan now is to create like shelves for these two parts to be attached on. And we have to think about the orientation that we're printing this. So I'm going to print it in this direction, more or less, so everything goes upwards in the printer. So that means that if I want to have a shelf over here, if I don't want to use any support, it's on Daniel. But Daniel's boat is like much cooler. All right, Michael. I'll see you later. Thanks for stopping by, and thanks for the help with the bear, the boost, and the build plate and leveling. So what I'm doing now is that I'm going to create shelves that can be printed in this direction, which is a bit tricky, but I think I have a plan for that. So basically, I created this here, and this is a offset plane. So this plane will help me create a shelf. So I'm going to sketch on that plane. I'm also going to intersect with some surfaces here, just to get some references. And then I want to position, let's go ahead and just look at it from above. So where did we do the second rib? We did it over there. I think I want to have all of those parts in the front here. So actually, to be honest, we could do it on the rib. But no, let's do it on this side of the rib, just so I can actually teach you something. So I want to make something flat here. Let's go ahead and make it 25. And for example, 30 millimeters. And then all the way back to this surface. So the plan was, why is it not a section? There we go. So now we have a section here. And my idea is that if I basically just do something like this and extrude that into our body, let's go ahead and join that. Let's make it 3 millimeters. So we will have it like this, and we then print it. It's gonna be, it's just gonna make a mess, really. So what we can do is that we can start to connect this by using 45-degree paths. So I'm going to intersect this plane here as well. Go down, hit that one. Or maybe if we're printing in PLA, we could go ahead with what's it called, 70 degrees. So let's go with what's the angle here now? Should be 60 degrees. Okay, it should be 30 degrees then. There we go, down to this spot. So you see here now that I created like a like an angle here. So let's extrude that inwards. Let's join it. It should be 3 millimeters as well. So see now, when we start to build, it's going to be easier for the printer to actually build this overhang and then land on another edge. And to make it even, more sense, I'm going to offset. What's it called? I'm going to create a line here inwards. I want it to be parallel with that one. Good. And you can just continue down. I want to have a distance here. That is, how do I make that distance? Okay, let's offset, but not the chain. Offset by 3 millimeters. So that gives us this surface, and then we can do, what's that called? Extend to objects. There we go. So now it does it all the way in. So see, now we have like a shelf in here, but this shelf has an angle. So this plane here is angled. Let's measure. It's 120 degrees, which is also 60 degrees. Depending on how you're looking at it, which means that when you're printing, you can always do some overhang. So in this case, we can do a 60-degree overhang, which means that we can actually create this plate even if it's in the middle. So let's go ahead and I'll just show you how I'm envisioning this. So let's save. I'm going to cut this model as I'm planning to do. So split this body at that stage, repeat. Split this body at that stage, and then we can join this and that, combine this and that. So see, now we have 3 different bodies. Oh, by the way, we don't need to look at that. So we have that body, and we have that body. So that means that if we look at this from this side, let's just make this as front. So like this means that however you're printing this, these shapes should all be able to print it on a 3D printer standing up. But especially this like plateau, this surface here is quite nice and should be able to print fairly easy. We can actually change this angle. I think we can go back to that sketch if we want to. Was it this angle? Yeah. So if we increase this angle here to, let's say, 40 and finish. Thank God for parametric leveling or modeling. This means that now we have a easier shape to print, and we can actually round this off just to make it a little bit easier for the printer. It looks gooder, looks better. So now we have an angle here that's just like an overhang, so it's printable. So that's how I really don't want to use any support in this printer, because it's such a mess having to deal with support, and like a boat shape should be fairly easy to do that. So this is a common way how to add flat surfaces that otherwise we need some angles. And hopefully, if I thought about everything, I should still have place to use here. So let's just back up a little bit before I started to cut everything up and down. Like so. And this was the top view. So let's make that top view again. There we go. So the whole reason why I did this is because I want to have, for example, the ECS, or the electronic speech controller. Electronic speech controller. I want the speech controller to like sit and live on top of this part. And let's see, I think I can't really remember exactly which side is which. But yeah, it could even live something like that. It doesn't matter, as long as there's a surface that we can put some Velcro on and stuff. capsule position. And if I remember correctly, yeah, okay, these ones are for the motor. These two are to the battery. And then we have the what's this called? The connector, the 3-pin for the receiver. So there we have a shell for that. We should also position the receiver somewhere. Maybe, I mean, I'm thinking on this side, but if we want to have the, what's it called, the antenna going up somewhere, we might even want to move it like this. So I'm thinking that we can basically position this on the rib. So we don't need to think so much about this. We can just take a zip tie here or something. We could make some space for that, but basically this is where the antenna goes out. Let's do it like this so you see it easier. So we have the receiver and the antenna goes up there. So when we have a lid here, the antenna will just like pop up and hopefully get a better signal. But yeah, the motor's cable should be just laying around here and they connect to this side of the ECS. And maybe even if like the battery is over here, we could have the cables just go down either through this side or down there and up to the other side of this thingy. And we also have, like, if we look at the real thing, oops, sorry about the noise. Let's just have a quick look at the real thing. So here you can see this is again the motor part for everyone's new here. The motor, we have the cable. The cables then go into the ECS that we just mounted. And from the ECS we have a battery plug. We have a resistor, I think, for the OBEC, which means 5 volt out. We have an on-off switch. And then it goes over to the receiver. So we have plenty of wires for getting everything in there. Cross. You mean like a? I'm not sure exactly where. Are you thinking about? 3D layers. Perpendicular to the surface on the bottom from center. Yes, you could make it perpendicular from this one. So you're thinking about, for example, we could put it you're thinking like this or something similar? I was thinking that as well. We can do that here in the front. We can have things popping up, but that's going to be printed again in that direction. So the layers are going to be pretty weak here. And also, if we have like a plate like this, I'm not sure this is what you meant, but if we have a plate like this, that also means that we can't really get the battery down. So we're kind of stuck here, and we're stuck to like get things down into the boat. I might do like a shell that goes inwards a little bit. I don't know if I can I push this in? No, I can't. Can I do like this? Press pull, new offset. Nope. Oops, I think we got a crash. Ah! No, oh, good. One thing we can do that's pretty fun is that you can offset a plane here. So one thing would be that we offset like this. Oops, that was a bit much. Something like this, and that we then basically, I'm going to do a little bit quick now, but basically we create this shape around the boat as well. Something like this, which gives us more space to put a lid on and everything, and we can still reach like all the different areas that we need to reach. So we might do something like this. Extend it to the other side. Yeah, of course. Okay, yeah, I'm gonna back up here a little bit. Like so. Yeah, of course we could do that. Yeah, we can lower it down to the battery. That's a good idea. Yeah, we can do that, and we can make a hole for the motor. So when we push down the motor, it would still work out. Good idea. Let's do that. So let's back up a little bit. That's actually a really good idea. Then we have that surface that we might want to, and we should also get some strength from it. So in theory, that means that we would actually have to remove, or we can do that later. So this one here would also intersect with that plane. And then we would create, I mean, in theory, it could go all the way up, but maybe let's leave some space for cables and stuff. So this should be perpendicular to, where's my axis? Like so, and you should basically just go all the way through. And the same goes for you. There we go. So you mean something like this, right? That's a lot of overhang, but we can do the same like angle down. But yeah, it does work. But then we could do it already from this rib here, because this is the bottom of the part. So we could do that going upwards here, but then we have to have a hole for the motor. So we've got to get the motor down somehow. So if we finish this here, we're going to have some issues with different things. Let's go ahead and look at it from the side. So that's going to be okay. Yeah, something like that. Yeah, we'll still have to add the 45 degrees, but I think that's good. And I want to leave this space here so we can route any cables and stuff like that through there. Let's see, this angle should still work, right? Yeah, it should. Okay, I think we need to stop here a little bit. Two sides, and on this side we also wanted to go to object that one. That doesn't work, does it? Nope. Okay, so let's delete those. And I think that we can do, there should be a tool for that. I think there's a rib tool. So let's go ahead and project these lines from the boat here. So let's hide some of the things here that we don't need to see. And does this work? Two objects. That doesn't work because it's on the inside. I think if I do like that, I can then just cut it basically, and it should work. But we're creating quite a kind of big rib here. Not sure. Yeah. Okay, I see what you're thinking, but I'm actually gonna back up. The reason is if we do like this, so let me just show you what I meant. Where's that body at? Oh, let's not, yeah, let's make a new body. Oh, it's in that component. Okay. Like so. So even if we split those bodies using the splitting tool here, of course, that's how we do it. And we split that body using a few different tools. That should work. Okay, but basically what I'm a little bit worried about is that we have a motor that we have to round out anyways. And if we round out that, that means that we kind of have to do, let's go ahead and do something like this, some extra space. Come on. That should be, yep. That would kind of mean that we have to cut in more parts than I actually want to. So we will have to do something like this, and then we end up with angles anyways. So I see what you mean. I think it might look cool. Never mind, we'll cut those out. But I'm gonna actually go back up to the original plan, which was something like this here. There we go. So I'm backing up because I think this will work better to leave us a lot of working space. So sorry for doing all that just to show you what we could have done. I see there's a few new people in here. What we're doing today is that we're taking my RC parts. We're taking this motor here and this water jet, and we're actually creating a boat around that we will be able to 3D print. So that's what we're doing. You can see we have the jet down here, we have the motor over here, ECS here, and receiver somewhere around that. And we'll probably keep adding things so that it looks good. Okay, so in the hull, I think we can do the last rib now before we start to actually do holes for the jet and try to make everything actually work. So let's hide some of the things that we're not using. Oh, by the way, I want to... Yep. So let's make another distance here. I think maybe 80 could be nice. Whoops, minus 80, that should be. I think that might be a good place to intersect or create a new hull as well. That means that like the distance between this and that is... Why can't I see that distance? Are those at an angle? It's going to be 100. Okay, so let's make this distance 90, which means that it's going to be easier for everyone to print. So let's make a new sketch on that one. We are going to intersect the boat. All of the bodies, that's all we needed. And click OK. I'm doing some 3D but 2D sketching. And we can do the same procedure here where we offset everything a few millimeters in. Let's go with -10. Will that work? -8. We did 8 on the first, 10 on the first one, 8 on the second one, so let's do 6 on this one. And we could add some, like just some strength in here in the middle. Let's make it 10 millimeter wide. Just make it go through everything. And then we'll start to trim it all the way. Something like that. There we go. And we'll make this 3 millimeter as well. It should be a new body, and that should fit well. But let's still make it a new one so we can still change them and work around a little bit. And if we do my next favorite thing, which is to fillet. We just gotta fillet these ones here as well. There we go. 4 millimeters. I think I used that on the previous one as well. So these are our ribs, our profiles, which looks pretty well, I think. What do you guys think? Is this all Greek to you, or are you kind of following along? Is there any questions, anything that looks weird? Just let me know. I'm here to answer questions while doing some 3D modeling, which is kind of what I love to do. Okay, so we also, of course, need to have a servo mount somewhere. And I actually completely forgot to add in the servo components. So let's jump over to our main component, the top component. Let's open our list. I have this servo here, for example. So let's add that. That's a 9-gram SG90, like a micro servo. And I think that, yeah, the way I want to do this is that I will select. We have a lot of things in the way here. I will use this point. I will use that point as my pivot points. I will rotate around, and I will actually grab a point. Or I guess not. I will grab this and let's move this over to the water jet. Something like that, and something like that. Something like that. Oh, they're almost aligned. Yeah, okay, that's close enough. Or actually, of course, that's not the point that's supposed to move. We need to add this one, of course. And to better fit these ones here, we can use a joint between that surface and that surface. That's not what I said. It's not taking the... It's taking the wrong points. There we go. Okay, cool. So that's a joint. It's yeah, it's okay. Good, because now I can move this around, right? Oh my god, it's... Yes, there we go. because I want, of course, the servo arm to connect to this one. And then we can move this inside the boat and figure out where the servo should be. And looking at this, I probably have to mount the servo upside down. So let's go ahead and do that. I'm guessing that's fine, right? I'm guessing they work in every way. And that's still on the same line, and I know that it's like popping up a little bit, so let's go ahead with 6 millimeters. So if we can find a space for the servo around there, that means that it will, we can make a hole around that and this connector, and those two will be able to move around and make it work, basically. So that's the plan for that. So we have a servo position. That kind of works out with the battery as well. Okay, so we need to figure that out, how exactly we're going to position that. But other than that, I think the boat is like, it's starting to get ready. So one more thing that we need to do is to, of course, make a hole in the boat here. Let's just go ahead and hide the inlet, because the inlet will be on the other side here. And let's see, this part also has to be further out. I'm thinking. Okay, so the first thing that we can do is that we can actually split the body. So I already have this model up. So I'm going to split this body by using this tool here. So that's the inlet for the jet, and it's actually extending all the way back here, but I don't think that's a problem. So if we do like we always do, we hide everything else. You can see now that we have a few parts here, or a few holes. So basically this hole here is, of course, for the inlet for the water jets. But this one here we don't need, so I'm actually gonna delete that one. And also delete that body, or remove that body. So this means that if we look at this from a cross section again, we have actually created ourselves the inlet path for the water jet, so we can actually get water inside. Of course, we are going to round that up a little bit, or fillet that. 1 millimeter should be fine. That means that we are getting some radius here. I'm not sure if that's good or bad, but it is what it is. Something like that should be fine. And also we need, of course, to cut on the back. So we need to create some holes here. Let's figure out where those are supposed to go. How do we do this best? If I hide a few of the parts, and if we do a projection here. I need to hide this body. So if we project that surface, and yeah, it's basically that surface that we need. We need to have that big hole. And that says 15, so let's go ahead with 15.2 to get us, or 4, to get us some margin. Whoops. Here we go. So that gives us some margin to make a hole. We also need to make a hole for the for these connectors, for these screws. So I'm not entirely sure how exactly those are going to be, but they should be kind of similar to how it looks right now. I know that it's yeah. Let's just project one of them. So one of these screw holes. Because I remember that actually, let's project all of them. Why make it more difficult than it actually is? And if I remember correctly, I already modeled these with a margin in mind. So if we extrude all of this through our bodies, like so, we would have all the connectors needed to get the jet in there. And we will make a hole for the server later on as well. But this doesn't look right. It's supposed to be a round hole. I don't want no weird holes, I want round holes. To make it a little bit easier again for myself, I'm gonna round off this hole. And that's gonna make it easier to push in the water jet's outlets. So let's go ahead with 0.05. And actually to, we need support if I do that. What I'm thinking now is that we might have like a lot of distance here between this part, like between the motor jet and the other part here. Oh, by the way, we should do, yeah, weird. But yeah, that should be all that we need. And while I'm at it, I see that I could do a chamfer over here as well to increase some strength on this part. So let's go ahead with a, is 5 too much? 5 is too much. 3? 3 should be fine without ruining everything. Okay. So, and then we have this part that this jet extension that should be further out because it's going to be screwed tight on this one here. I was thinking about making like a hole for that one, but that's gonna require support to print, and we don't want to have support when printing. Other than that, we actually need to make the holes down here. So let's draw here. Let's hide the body. Bring in the water jet again. And we can project these holes. And where are we? Zooming in, zooming out. And these ones are going through the boat, of course, to the inside. Cut. Let's go with symmetrical, both directions. There we go, we're cutting through. So we can actually mount that. And there's actually one of the interesting things here are that we have a like a small reference here. So if we look at the jet again and hide the body here, there's like a small protrusion here. So if we actually project that, so that line, that line, that line, and that line. Now the way we're going to print this, I think it's better to do like a small offset on this one, just to make sure that we have space. Let's go with 0.1. No, 0.5. 0.75. Let's add some margins. Which means that we can then extrude this one's inside a little bit as well. Let's select everything here. Let's 0.3, I think. And I'm not exactly sure why it's there, but it's probably some sort of location thingy. And I think this should be enough. We could actually do this offset a little bit more to let's do 1 millimeter to make sure that the nozzle can kind of get there. And this is all because we have this small indentation on the water jet, and I know it's a fact because yeah, we have it on this part as well. Okay, can I find all the parts I want to show? I had an extra part somewhere, but I can't find it anymore. Okay, so we are starting to get ready to think about the next step. Let's see, that's the hull. Everything there looks good. The only thing that we haven't really done something about is the battery. So if we rediscover all the parts here, of course we haven't mounted the servo, nor have we made a good solution for the battery to like slide back and forth. Oh, we don't have a motor mount yet as well. So maybe we should focus on the motor mount, because it feels like the motor is pretty important. So this is where our motor will be. We will have a wire coming out of this place. So that's actually good to remember. I'm thinking that we have 2 screw mounts for the motor here. So the motor will be screwed together over here, but I don't think that's enough. I want to have something that the motor can rest on a little bit. So I'm going to make a something that goes out, let's say 35 millimeters. I will create a sketch on that one. I will intersect the boat hull. Oh, by the way, I'm not in the... Let's back up a bit. Let's go into the hull component and then redo everything. 35 millimeters, like so. Create a sketch on that. We will intersect the hull. So we'll use all the parts that we need. Like so. We can intersect the motor here as well. I did move the motor a little bit, like in the angle, like it's actually angled on the parts. So it might look a little bit weird when we're doing this. By the way, we can hide those 2 planes. I'm gonna add a little bit of margin because we don't exactly know how it's gonna behave. And let's create go with 5 millimeters up. So this is what I'm thinking. I think about having something that just kind of holds it in position out here. So if it's any vibration, it kind of works inside here. How do I actually need to do this? Let's go with 3 millimeters. Let's join. Let's not join the motor. Let's go with 4 millimeters. So that's some sort of mount. Let's see if we can just chamfer this. Oops, not fillet, chamfer. No, that doesn't work. I think this will be printable anyways. Yeah, that's gonna be printable. That will work. It will work somehow. It's not that important. What I kind of want to do is to have something that we can actually screw down the motor with. So if we bring back the motor, it will kind of rest down there. So if we want to have something that we can screw in, we want to create, yeah, okay, let's do that. Let's create an offset from the bottom. Let's just look so we can see the motor. Let's go ahead with 18 millimeters. I'm now thinking. It should be 18. If we do a sketch on that, we intersect that model. Intersect the motor as well. So I'm thinking that what we can do is that we actually create like off center. We do 70 millimeters out, and then we do like basically all the way. Yeah, let's go with 40 millimeters up, 6 millimeters wide. Ooh, and this one should be parallel, of course. There we go. So my plan now is that if I extrude this and go down here, extend to object to those two. Can I make a join? Yes, I can. Good. So I'm thinking it's I really wanted to have like some nuts in there, something that I can block off with, but I want to have if I mirror this. Yes, Jimmy, yes, of course. This is going to be super radio controlled. So let me show you in a second here. Thanks for stopping by the way. I'm just trying to orientate myself. Okay, there we go. So in theory, if I combine that and that, make them join. There we go. So I want to have a it's pretty difficult. I don't want to thread into this plastic part, but I'm thinking that before I push in the motor, I could in theory push in a nut here from the side, which means that if we make a hole, like 2 holes up here, we could have like an arc going above that we print separately and that we push down. But yeah, for Jimmy and for everyone else that's new here, here's a quick recap on what's happening. So this here is a radio control, or going to be a radio controlled boat. So we started off with this part here, which is a RC jet, water jet that I purchased, and looks something like this when mounted on the motor. I 3D modeled that, and then I want to create a boat around that. So we started with that part. We have the motor. We also have like the receiver, the ECS. There's going to be a few wires, of course, the battery somewhere. And then from that, we started with a hull. So we started to create this hull where it's going to be divided into 4 parts that you 3D print, and probably like a lid and maybe some smaller parts as well. And hopefully that's going to be a boat that floats, first of all. It would be nice if it floats. It would be really nice if it works. If the water jet is below water level and everything is, yeah, going as planned when it comes to driving it. So yeah, we're almost at the end stages of the first concept where we can actually print something and put it in the water and see how it looks. So yeah, by the way, if you enjoyed this stream, there's a link below the stream where you can send me a coffee, a beer, or just help out with the channel and paying the bills in the corona times. It's also my 30th birthday on Wednesday, so if you want to send me like a beer as a gift, go ahead and do that. Thank you. So let's continue. I am thinking that what I usually like to do with some parts is that I make a square where you can push in a, let's say, a M3 bolt, and then you have a hole through it, and that means that you can screw that part together. We could also do like the melt-in inserts. I do have some of those. Maybe we should do that. Unfortunately, I think they're a bit big size. So it's like these. Let's see if it can focus. Can you focus? These are some inserts that you can push into with a soldering gun. You can push those into the plastic, and you should be able to screw into those fairly well. So we might actually use those, but those are M4, I think. They're even bigger. That's not good. I thought I had some that fits 3D printers better. Maybe I used all of them. So, 1 second here. So I do have a few of them. I don't know if you can see here. These ones are for the M3. So I might actually just reuse these ones. So pull those out of this part and yeah, use them. Oh, this is difficult. So let's go ahead and take those. I don't need to make a hole for them because I don't have the measurements. They should be around 3.5 millimeters. Doesn't really matter where it is, so let's go with 3.5. Let's make 2 of them. I'm not sure I'm gonna actually use both of them. And dimension this one from that one. Let's go ahead with 9 millimeters. Good. And then we make a mirror line. And mirror those along this axis. So there we go, and we can then basically just extrude those down a bit, so we get some space to melt them down. Let's back up a step here. Let's just make that distance known. And let's go ahead with 8, because that means that everything is much easier when I do the next step, which is pushing these out 26 millimeters. Thank you, Jason. I'm trying to. I'm doing this more like an entertainment stream. I like to do more lessons, but I know that some people are really good. Some people don't even care about the modeling. They just want to see a cool project grow. So I'm trying to speed it up a little bit. But if you have like any questions, how did you do that or this, just write it down, and I'll try to integrate that and help you learn that. Yes, so the plan now is to make the clamp for the motor. So I'm doing a drawing up here. I also want to intersect these lines here so I know roughly where things are going to be. Let's go ahead and hide that body. So I know that something will clamp down around here. And I also have the body, like the shape of it. So let's go ahead and offset that a little bit. Three-quarters. That is a good tip, sharpness. I wish you were here early in the stream. I think you're right. I think it's floating a bit too much, and we might have to add some weight to get it down a bit. But I mean, my plan was that you see the inlet is down here. I'm thinking that it will float like around here somewhere. I'm thinking that should be where like the float line is. I don't know if you would agree. So the inlet, I don't know. What do you think? Do you think it's like super impossible? Because the inlet is, the inlet is down here, and I'm thinking it would float maybe around here with some added weight, maybe around here. Depends. I mean, if we go fast, for everyone new in the stream, I'm not planning on going super fast. The plan is to go like upstream to do some navigation, upstream, up creeks, up water flows. I think that could be fun. So hitting a lot of rocks and stuff. We'll have to see. I think we have to test, and then since this is all parametric, we should be able to go back in and change the hull shape a little bit. Yes, where were we? Yeah, we're going to do a like a clamp here. It doesn't really matter about the shape, but I want to have a distance from that. Let's go ahead with 6 maybe. And then we can offset this even more. Let's go ahead with 5. Yes! Thank you, sharpness. I'm much calmer now. And then we offset this one here as well. Let's go with -4. I think that should be sharp enough. And we can do this, and we can do that. Hopefully, now when I start to trim, I can explain what my idea was here. Yes, there we go. So this was the plan, to make a body. Symmetric. Let's go with 8 millimeters. So I'm imagining that this would work like a clamp, so we would be able to tighten down the motor, and then we have this mount down here as well. Let's select that. This one here, so we actually help like clamping it in a little bit. We can do an whoops, stop. We can do like this, hopefully. Let's use those. Cut through. Cut. Bada boom. Always add fillets. Oh yeah, by the way, this one here should be, of course, a component. Motor clamp. That's what we're gonna call that. And then we'll just add some screws here to push that down, and the motor should be in place. Okay, so now we have motor mount, we have a quick and dirty solution to get the receiver here. I'm just thinking to add some oh, what's that called? Zip tie. But we might actually, because we kind of want to test it out, I will build, like on the real version that we'll sell, I will build something that there's some weird traffic outside. Something that will keep it a little bit better in place, but we'll start with that. Hjalmar, your boat had issues with floating ore? If you want to show me a picture or something, you can tweet me via the links down below, because I can't see it in the chat here. Yeah, sorry for that short minute of thinking, of silence. Yeah, okay, so the next step is to fit this servo somehow, to make a good position for that, so that we can also get that to work with the screw. There's actually an extended part here that pushes it up a little bit. So, how do we do this the best? We kinda have to have it in this direction, but we might be able to turn it around. So if we move this, we kind of want to move it around that point. But of course, in that direction we can turn. And in this direction, it would look weird. I'm not really following along, Hjalmar. Sorry. Okay, maybe we can turn it around. Maybe we have to have it in this position because we need to have some leverage on the arm so we can pull this in and out. I mean, it's not going to be a lot of force, so we could, in theory, we could do a like a mount here. So if we do a offset plane, how far is it to that surface? 24. Let's do 24.5. Let's make a sketch on that. And let's project that surface, this, and that didn't work. Let's hide the hull, that surface, and that surface. Oh, and of course we should be working in the hull. Can I move that sketch in there? Yes, I can. So we want to make some sort of mount here. Oops, it's this sketch. There we go. So I'm thinking that we should be able to do just something like this. So if we just close this off here, you see we have this surface here. In theory, if we push this down here, let me join that, we would have a mount, and it would be printable, everything would work, but it's not beautiful, and it's quite impossible actually to get the screw down in here, so we would have to screw it from this way. Because adding something over here is very difficult because we would have to use support, and I'd rather not use support in this print. So either by having like another part that we screw on that then would clamp it, I'm not sure that's how I want to do things. But of course, we could, yeah, of course we could do like this. So if we only take this one here, so if we made a plate like that, we would have somewhere to at least put one screw in. I don't know, it's not perfect, but it would work. We could add some ribs here or something to make that stronger. But it's this location where, because again, we're printing with this surface down on the build plate. Maybe we can do, I don't know, man, that's gonna be pretty difficult. I don't think we can actually screw it in, but maybe we can do something that we glue in. Which is, it's not pretty, but it might work. Do any of you have any idea how to solve this? Because I'm kind of stuck here, and I don't just want to glue it on one side or put a screw here. I kind of think that we need to put something on this side that's strong enough. It's like maybe we can print in an angle. And I mean, I don't want to make it too complicated with 3 parts screwing all together just to mount a mount here. So maybe, because we are a little bit lazy today, we'll make one part that you have to glue on. I think that's acceptable. So let's make a new sketch over there. Let's intersect the hull. And I mean, I like glue. It's not that I don't enjoy gluing things, but it's not always the right call. Let's make one line over there and one over there. So in theory, if I do like this, so if we make this part here, and if of course we kind of have to Okay. Let's cut this part as well because it's not flush. So we need to split that body with this part without extending the cutting surface. There we go. Now we should have a body and another body, so we remove that one. Now those two should be flush together. We could take this part and basically just print this part here. And then glue, using glue. Okay, is that okay, or is that like the simple way, or are you disappointed in me because I'm not doing the right way? Oh, and of course, if you are smart, we have to think about how the servo is going to move. So because this is printable in that direction, let's go ahead and just make some space for the servo here. That's what I'm thinking, that the servo is might hit that actually. So we do something like that and add some fillets to increase strength. 0.8 or something. Ah, super. Thank you, Hjalmar. Hey! Okay, Hjalmar is... I'm going to show you here. This is Hjalmar's boat that he sent me. It's also a turboprop or a water jet. And did you have an issue with it floating too high up? Because that looks pretty cool. That's a really nice job, Hjalmar. Hjalmar's in the chat down here, by the way. Yeah, so this should work with the motion, and everything's going to work over here as well. It might not be super stable, but I think it's going to be good enough. So let's create a new component from this one here as well. This body should be a new component that is called, oops, let's make that component up here in the main body. We call it servo holder. Let's call it servo holder. So there we go. And then we need a small hole on the back here. So did you add, Hjalmar, did you add some weights or something to keep it down? Okay, I want to project where the servo arm is, or where like this hole, where that hole is. Come on. Yes, project that. There we go. Okay, so now we know roughly where the hole is. So let's make a hole just underneath this one here. Let's go ahead with 3 millimeters. I think my wires are smaller than that, but 3 should work. This doesn't feel right to add a hole in the boat, but I guess that's what we have to do. All right, so nice, but it worked well after you added the weight, or? It looked good on the picture. I'm guessing that I have space to add weight like around the motors down here. Oh, by the way, did our motor mount is pushing on the battery. That's not good. We need to fix that. So let's go ahead and go into the motor clamp and cut that body. Split the motor mount with this plane here. I'm going to extend that. It's going to be a bit thin, but I think it will work. I don't know. So now I just plane that off, the motor mount. And yeah, let's redo that. I think it's still strong enough, but again, it is screwed in, so I don't think we need to have that much force in it. But that also means that, to be honest, the battery can kind of rest on this one here. So if we add in the battery again. Okay, let's do some figuring out things here. If we're gonna have the battery where we might have to move this a little bit. That should work, 10 millimeters. Then we have to move it up, or because now it's hitting the hull. We don't want that. So maybe, what if we do like this? Rotate! Exactly. Yeah, I'm thinking somewhere here. I don't have any screws or anything on this. I just want the antenna to be able to pop out of eventually a lid. So I guess this is a good position. All the cables are high up, if there's any water inside the boats. I think I'm gonna go with that, and that actually means that I might, yeah, we can still zip lock it around here. Let's capture the position. Let's go back into this component, and I want to change this shape here now. So I kind of want to trim off a little bit. So I want to trim off, let's go ahead with roughly there. Which means that if we go ahead with this part, I don't want to extrude. That didn't work as planned. So if we cut away these ones here, no, it didn't really work as planned. Why can't I select it? Ah, I don't have the sketch open. There we go. That's not what I want to do. I wanted to do the other way around. There we go. Yes, finish, but I want to deselect that one. Select that one. There we go. No, that's again the wrong one. I want that to be open, but that to be closed. There we go. Thank you. So now I should be able to put a like a zip tie around this one here, just to make it sit tight here. I might even do like this, where I cut down 2 millimeters. How wide is a zip tie? Let's go with 10 millimeters and go up here again. This is just so I can squeeze in. Even if I put on a lid here, I will be able to squeeze in a cable tie between these surfaces here. So like between these surfaces and around the, if I don't want to glue it. Thank you, Hjalmar. Yeah, I agree. Like the way the battery is now, it's I can't really get it down much further. You see, compared here with the motor and everything, I think that's like really on the edge. Hopefully I might be able to add some weight here. I could potentially put the battery around here, but we had an expert before. Let's see, who was that? That was Taskin. Taskin was here telling me that I had to have the CG around 30% from the rear. So that's why I have it right there now. Awesome. If we run into issues with weight, I could potentially move the battery to like sit down here much further forward, but then we can add more weight like in these areas of the boat. So we just add bolts and nuts and lead between the water jet and here, just to kind of really keep it down. But yeah, right now I should be able to squeeze in a lot of like papers to by the way, how should I I might be able to put a zip tie or something to place the battery down here as well, to kind of keep it down. I think I have to figure that out and move the battery around a lot when testing. So yeah, one thing that I was thinking about doing to make it easier for me when I want to create like a lid is to actually draw like a few pieces here. So let's go from the center, let's go 60, that's 120. Like how wide is my hand? 120, I can reach in there. Just figuring out, let's go 70 just to get some space, or 65. So what I want to do is to basically should be 70, right? Yeah, I think it's 70. So I want to add these surfaces here where we can actually print. So we have, how much is that we have? We have 4 millimeters, I think. But we offset, just give me a second here. Offset plane 2 millimeters downwards, -2. And make it 2 millimeters thick. And join. So what I wanted to do here was to like create some, even 3. Maybe even 4. Yeah, let's go ahead with 4. Create some flat surfaces that makes it easier to put a lid on later on. Let's go ahead and make new body, mirror that body. The XY plane. There we go. We could do it later on, but I might think about adding those later. And to, let's see here. Yeah, that should be good. We should push that surface to be connecting with. Okay, never mind. So, that's it. I think we're ready to start splitting this body up. So let's go into the hull. And let's start splitting. So we're going to split this body on that plane. There we go. Which means that we have, if we hide that one, and we hide this one, this means that this body here is one of our first printed test parts. Let's add a fillet. I can't add enough fillets in whatever I do. 3 should be fine, but I can see that the surface is kind of, there we go. If I delete that, there were probably some leftover surface, because now we have a clean cut here, which makes everything much easier to print. And that will then, let's call this rear, and hide that, and then we continue cutting here. Let's split the body again with this part. Mid rear is a good name. So let's add this part here as well. Let's join those together. Make sure, yep, we have a good clean cut here. That's exactly what I want to see. And so that's, let's see. So that's our next part, the mid-rear body here. We have a lot of surface to glue here, so we should be fine. And especially if we look at like how these surfaces connect. I mean, if you want to add some epoxy or some glue here to really seal, make it watertight, I think that's a good idea. We might add, like later on, we might add some things here to, like some rivets that goes down that can be printed in 45 degrees, so we can actually screw the things together and add some strength. But we'll have to test and see. It's not going to be like a super fast boat. So I think it's a good start. Yes, so we have mid, we have rear. Let's go ahead and do the next step, which is to split the body at this surface. Perfect. Then we add those two together. We will call this mid front. I'm so creative with these names. It's really impressive. And then we add those two together and we call that, drum roll, front. All right, so we have our sections. We have all the other parts in our boat. It might be a strange shape, but hopefully it works. I guess we have to see. And yeah, we have spaces for all the wires. Things are like hot glued in place. Let's go ahead and check for. Isn't there a tool for like check collisions? Interference, everything. I want to check everything. Ooh. Compute. Okay. Let's not do that again. We have this hole here. I'm sure that there are some ways to maybe we can add an O-ring, or if there's any way of adding like a tube or something to avoid getting water in there, because I'm pretty sure that's below waterline. I'm pretty sure. Another way would be to so like you see here on this extender, let me show you on this camera here. So you see that's the extender for like steering the servo. We might be able to put something taller on that one so it sticks up even more, being able to move that hole up even further. Okay, let's make a test here. Let's just check how big these things are, because I have not really checked the width of it. Boat test rear. I'm gonna open up Cura. That's just a spacer. Whoops. I want to test how big this actually is, but it looks manageable. Yeah, I can do it in both. I could print a lot of parts overnight here, but usually I like to do something like this. So this is, yeah, obviously the size might be a bit big. I haven't actually checked the size, the width of the boat. So it's roughly 170, but that's good. Most people have like 200mm print beds, so we should be fine. This should work really nice. Otherwise we had to split it again. Okay, so let's just check Cura. Let's go with some, I guess, standard settings. What are these? Let's go with 25mm layers. I just want to see like a rough estimate on print time to kind of see when we can expect to have this done. 3 shells, I think that's pretty good. Infill density 15, maybe. We don't have a lot of details. We can probably speed it up a little bit. 70 on exterior and 38 on interior walls. So before I slice this, what are you guys estimating? Let me know down below. How long do you think it takes to print one segment? Take your guesses. Place your bets. Any suggestions? Hmm. 11 hours. That's a good guess. Let's see. Oh, wait. Jesus Christ, I had the wrong screen on. You have to tell me when I'm not showing you guys the screen. This is actually 4 hours and 46 minutes. That's pretty decent. Probably be a little bit too fast settings, and we don't have a lot of top and bottom. I only have 3 top and 3 bottom. So that's pretty nice. That means that we could, in theory, have a boat ready pretty soon. Yeah, I think that should work pretty well. These screw holes might be a bit thin, but yeah. Jesus Christ, guys, you have to tell me when I have the profile camera instead of like the video. I don't think you want to watch me all the time, or I hope you don't. Okay, so I think that's all we can do in the first step, which means that now this is going to be a week with birthdays and more work to do. So hopefully I can produce some parts, put it all together, maybe do a first test drive by the end of the week. We'll see if there's a lot of like errors. I'm probably gonna share a lot on social media, but if you want to, you can always become a patron. I have some more cool models. For example, you can get, if you do a Patreon for, what's it called, $4 Patreon down below, you get the files for the SpaceX shuttle as well, if you want to have that and print and play with, and like any other parts. So that's the shameless plug, or whatever it's called. So you can find that link down below. Yeah, I'm gonna share the story there, and I'll probably make a YouTube video about it as well. But yeah, that's probably everything for today, unless any of you have any questions. Just let me know down in the comments, and yeah, thanks for stopping by. So let's see, I'm gonna wait here for a few seconds and see if someone has any questions. Did I miss anything? No. While I wait, I'm gonna do some cool spins. Maybe even do a render. I think this can work. This could work. I should probably make some holes for the screws here, or maybe not. Thank you, Jason, and yeah, all right, looks like no questions, so thank you so much for stopping by, and I'll see you guys in the next video. Bye!